This week, we're going to look at circles, but we're going to look at them in a coordinate plane. And today we're going to try to figure out the equation that you would use to write a circle. If you look at the investigation that I put on Schoology, it's what we would have done in class. I would have you plot these points and use a compass, and you can see that they're a circle. You know, this one's at 5, 0. This one's at, 4, 3. This one's at 3, 4. This one's at 0, 5, and so on, and I could go around the circle. Now you'll note that the radius of the circle is 5 units, because you can draw any line segment that's connecting the center to one of these endpoints, and I know that they're all 5 units long, and you know how I can figure that out? Distance formula, which is basically the Pythagorean theorem, right? This right triangle here has a side that's 4 and a side that's 3, and 4 squared plus 3 squared equals 5 squared. So the radius of this circle is 5 units in, every which way. It's 5 units this way, this way, this way, and this way. And then all these other ones are also 5 units. So let's see here. If I wanted to come up with an equation for this circle, an equation of circles, or of anything in a coordinate plane, takes the x and the y coordinates and it relates them together. And so let's think about this. The radius of this circle is 5, but each of these x's and y's, like 4, 3, 3, 4, 0, 5, and so on, if I were to take those two numbers and relate them together to make an equation, it would just basically be the Pythagorean theorem, because the radius is the same all the way around this circle like this, right? And so if you're traveling around the circle, basically what we would do to find the equation of this circle is we take whatever the x coordinate is and square it, because that's one side of a right triangle, and then we would add the y coordinate squared, and you know what that would equal? Well, it doesn't equal the radius, it equals the radius squared. That is the equation of a circle where the center is right here in the middle at 0, 0. And you can try it. 5 squared plus 0 squared equals 5 squared. 4 squared plus 3 squared equals 5 squared. 0 squared plus 5 squared equals 0 squared, and so on, right? And we could do this with the negative numbers as well. Like this one's at negative 4, 3. Negative 4 squared is 16, and 3 squared is 9, and that still equals 5 squared. And so this, my friends, is how you write the equation of a circle in the coordinate plane. It's just the x-coordinate squared plus the y-coordinate squared equals the radius of the circle squared. So your job on this worksheet is to figure out, what do we add into this if I want to take the center of the circle and shift it somewhere else besides at 0, 0. So here I took the center of the circle and I moved it over 4 units and up 1 unit. And that's what you're supposed to do on the worksheet. Well, you're supposed to take all those other points and also move them over 4 units. So 1, 2, 3, 4, and up 1 unit. So this point here that was at 5, 0 is now at 9, 1. And so, but I do know that the radius is still 5. And so you're going to shift all those points and think, well, what would you do to the x and the y to make it so that it still equals 5 squared? You have to figure out something that's going on in here, and I'll give you a strong hint. It has to do with the coordinates of the center of the circle.